Hi, everyone. Today we're on lesson 4. You'll lose some, you'll lose some, right? Our learning targets for today are understanding the form in which a quadratic function is written can reveal different key characteristics. Remember, we learned 3 different forms, and each form tells us something a little bit different. And then also show different rearrangements of quadratic functions in general form, factor form, and vertex form, and analyze their properties. Also, we're going to be comparing properties of quadratic functions represented in different ways. So one may be an equation, another one may be in a graph or in a table, right? And then also use multiple representations of quadratic functions to identify key characteristics such as maximum, minimum, intercepts, and the axis of symmetry. So for our do now, we found, it says right here, write the ordered pair of the y-intercept of each quadratic function. So that's what we did. And let's see here. This was in factored form. So we did this here down here. Remember, whenever we're looking for the y-intercept, that's when the x is equal to 0. Because remember, on the y-axis, what is the value of x? 0, because we're not going to the left or to the right on the x-axis, right? So always y-intercept, plug in 0 for x to figure that out, right? And we plugged those in, and we found that it was 0.24. We're going to write that as a point because the y-intercept is a point, right? And then for number 2, same thing. Notice that we're putting f of 0. So anywhere you see an x, you're putting in 0, right? And then we got 0 in those 2 places. Just make note, when you go 9 times 0, it is not 9, it is 0, right? If you have 9 groups of nothing, what do you have? Nothing, right? And then our result is -5, so it's just going to be 0, -5. Honestly, if you're like, you looked at that and you're like, I know the answer is just -5, you don't have to do this middle work. Not necessary. But if you want to, I am not going to stop you. More work is better, so that I can see how you're thinking. All right. And then the last one right there, for number 3, we just, again, plugged in 0 in for x. 0 minus, a lot of people make that mistake of saying, oh, 14 is it? Because it kind of looks like the number 2, where it's just the -5 on the end right there. But we can't say that because remember, the 0 is attached to this -1, right? 0 minus 1 is not 0, right? It's -1. So please make sure you don't make that mistake. All right. And so our y-intercept is going to be 0.19. And if you had not done those before, I would like try and do them by yourself. And then what we did here was go to the very back of the book, the lesson, not the book, and talk about a few things. I'm going to go back up to that. All right. So remember here, this is on page 85, right? And we have these graphic organizers, one on the front, one on the back. Right? And this is kind of a good summary, right? So if you look at this right here, if we have general form, i.e. standard form, right, there are 2 things that it tells us. And I tried to color coordinate these. We do know, remember that leading coefficient right there, that first number, that's going to give us whether it opens up or opens down, right? So in this case, since it's positive, it is going to open up this way, right? And then we also know very easily the y-intercept. Just by looking at it, we know that that's going to be -3, just like how we found out in our the do now, right? If we were to plug in 0 in for x, it's just -3. So we know that that's always going to be the y-intercept. All right, and then we graphed it on Desmos, and we found that the roots were -3 and 1. Notice I did not put parentheses around here because I don't mean the point -3, 1. I mean the roots are at -3 and at 1. Okay. And then we found the vertex was -1, -4. If you've never used Desmos, you didn't practice that in class, I would practice that now. Okay, so make sure you know how to do that. Let's see here. So here we're going to have, remember we had it in factored form. So remember our factored form always looks like, let's see if I can get my highlighter out, or not my highlighter, my pencil out pen. So remember in factored form, it always starts out like this, right? I always like to set it up first. I'm just going to use a different color to show. And then we're going to put in our roots, right? So remember, normally it's supposed to be a minus. Then here is our R1 and R2. So it's going to be -3. So I go like this, -3 and then 1. All right. So that I don't have to rewrite it because I don't want to rewrite it as a minus negative because that turns into a plus anyway. So that's me just doing that. My little shortcut way, right? And then in front here on us, we're just taking the same standard form right here. So that's just going to be like that one right there. Normally we don't put a one. If we look at that, we're like, oh, we don't put in the one there. We assume that's already there. That's going to be f of x. All right. And again, factored form always tells us whether the parabola opens up or down. Remember this, the same a. It goes all the way through all three forms. And plus we know the roots, which are also called the zeros, which are also called the x-intercepts. Same thing. All right. And those are the only two things that it tells us. And then we went down to here for vertex form. And again, the form, remember, is if you go back and look at that, I'm just going to set it up. So it's going to be x minus the x coordinate and then the y coordinate over there. And this is literally, remember, our vertex was -1, -4, so it's going to be -1. So same kind of thing as what we did for the roots, -4. Okay. So I always think whenever it's in the parentheses with the x, it's always opposite of what I'm seeing. So this is actually supposed to be a -1, because remember that was supposed to be a minus. Okay, and the other thing that it tells us, so it tells us the vertex. Obviously, that's why it's called the vertex form. And then the whether it opens up or opens down. And since we know the vertex by default, we already know the AOS, right? So we added that in there because the AOS is just, remember the AOS is the axis of symmetry. So is this part right here. And so if you remember, the axis of symmetry is on the vertex, right? So it's always the x coordinate part. Okay, so it's in this case, it's x equals to -1. Right, and then we just graphed it over here. We took all the information that we knew. So we knew that the y-intercept right here was 3, right, or -3. So there's my -3 right there. And maybe I should just highlight that. So there's my y-intercept right here. We know that the roots, which made blue, are right here, right? So I highlighted those. And we also know that the vertex was this color. So this is the vertex. That's either the lowest or the highest point, which will give us the min or the max, right? And then where is this other point coming from? If you remember that this is the symmetric point. So how do we know? Is remember that it's the line of symmetry, right? So this is the axis of symmetry. So if we know that the point right here, the y-intercept is at -4, then we know, and that's only one away from the axis of symmetry, then we know that on the other side, it goes that long, okay? So that's why even it's not any of these things, but we do know that that's also a point on the parabola, and that will help us to make a more accurate parabola. Okay, that's symmetric point right there. We know they're symmetrical, just like your face should be symmetrical. If it's not, then I don't know. But I won't be able to tell because you don't have your video on. All right, and then we did the same thing here. So I will just quickly go, I won't really quickly, it's the same thing, okay? We just went over this graph very quickly. I just guesstimated, I'm just like, okay, that's 32, that's 30, or -30 because we ran out of time. Remember, we got this information right here. How? By using Desmos. This is the only unit we're going to do that on. Other units, we're going to actually calculate that out. I'm going to expect those calculations. Only for this unit, I'm not going to necessarily have to see that. Okay. Let's see what else. And you could take a look at here, see if you got these things. So that's what's supposed to be 2 times x plus 3, x minus 5. And this one is going to be 2 times x minus 1 squared minus 32. And the way, remember, we got that by looking at the Desmos graph, and you would look at the different points on there. And let me think here. Oh, and remember, we got this a right here, this 2. We got that from here, from the general form. Okay. Because whatever that number is, remember that a travels through all of these 3 forms and it doesn't change its number. It just stays as 2. Okay. All right. So we're going to go on to, we're going to go back to the other thing. So, oh, right here, page 82. So we're going to compare 2 different things. So here we have an equation, and on the right, we have a table, right? So, and these are 2 drones in flight, a very short flight, not a very long flight. And so Kareen's drone and Ben's drone. And if you look at Kareen's, the question was, which flight began at a higher elevation, right? When we're talking about anything about began, we're talking about the y-intercept at this point. So when we see began, think of y-intercept, especially when we're talking about the elevation, like how high or how low it is. That's going to be, because usually at began, that's when your x is equal to 0, your time is equal to 0, right? So here our y-intercept was at 4, right? So Ben's drone started at 4 feet above the ground, right? And then if you look at Corinne's, remember what we just talked about, that the +1, that's our y-intercept right there. I'm gonna just label that y-intercept. So Corinne's drone started at 1 foot, right? So which one went higher? Ben's drone, right? Ben's drone started higher at a higher elevation because I could just say that the y-intercept is at 4, right? And Corinne's is at 1, okay? Which drone began descending first? So if you look right here, it's gonna do something like this. It starts up, it goes up, and it goes down, right? And so the question is, where's that tipping point? Do you remember this line? That is the axis of symmetry. So if you can find the axis of symmetry, we can figure out when that, right at the time at when it starts to drop, okay? Because remember, that's going to be at the highest point, and anything after that, it's going to start dropping. So, and we found that by using the AOS. This is the AOS formula, negative b over 2a. And remember, we need to get the b and the a, right? So remember that the a is going to be the coefficient of the first term right there of the x squared, which is -3. And b is the coefficient of the x, which is 7. And c, technically, we don't need it, but we'll just practice. C is 1. C is always the one that's by itself. I think C for constant, because it's the only one that has no variables in it. All right, so that's going to be negative b, so -7 over 2 times -3. And simplifying that, I get -7 over -6, which is 7/6, which is a little bit over 1 second. And I just wrote down 1 and 1/16 seconds, right? That's when it starts dropping down for Corinne, right? But what about for Ben? And if you look at the y values here, we go 4 and it goes to 4.25, and then it goes back down to 4, which means that this 4.25, this is the vertex right here. So the vertex is here. So it peaks right here at 0.25. So literally after a quarter of a second, what is Ben's doing? Shoo! It's going down. So it really has a short-lived going up, and then it just goes down, right? So it's just when you do your drones, does that happen? We don't have drones. We have those like flying airplane thingies or like helicopter thingies. And yeah, this is usually what it does for me, or just doesn't even get off the ground. Sad days, right? Definitely. Which drone begins descending first? So it's Ben's drone. Descends after, how many seconds? A quarter of a second. Very short-lived. Okay. I should have said Ben's drone descends first, which is after 0.25 seconds, but I didn't, sorry. All right, so we're gonna do some comparing here. So it says, actually, we're gonna just not do this one. We're talking about greater average rate of change. We didn't really talk about that. Honestly, it has to do with the slope formula, but we won't get into that. Which one has a greater absolute minimum? Unless you want me to. I kind of feel like I want to now. But which function has a greater absolute minimum? So we know our minimum right here is like at -20. So min at 20, -20. And here, if you look, it goes from 4 to 0 to 0. 4. I'm trying to graph this in my brain. So if x is equal to 0, y is equal to 4, and then y is equal to 1, or x is equal to 1, y is equal to 0, and then 4, 0. Ooh. It's going to do something like this. So I'm going to say that's definitely does not look like it's going to go all the way down to -20 at the rate this is going, right? So this one is, which one has a greater absolute minimum? So greater meaning less negative. So I'm going to say this one is, because this is definitely going to be bigger than -20. It's definitely not that low. All right. So we're going to go right here. What is the function's axis of symmetry? Oh, which function's axis of symmetry has a greater x value? Right. So let's find the axis of symmetry for this one. So remember, a is equal to 2, b is equal to, we don't have an x, so literally we just say 0, and c is equal to 4. And so x equal to -b over 2a. So let's try this out. Negative of 0 is 0. And honestly, it doesn't matter what the bottom is. It's 2 times 2. So it's just going to be 0. So x is equal to 0. That is the value of, that's the axis of symmetry there. And here it looks like it's -3 and 30, then 0, 0, and then 5, 30. So it looks like right here, these are two same points right here. So which means that AOS is going to be halfway in between those two, right? So literally I'm going to be like, well, -3 plus 5, divide that by 2. Because remember, we just find the average. Because if we have those two symmetrical points, we can find that middle number, right? Which is going to be 2 over 2, which is 1. So x is equal to 1 here. Oh, which one is greater? This guy, B wins. All right. And let me just show you really quickly. So if you're, so this is like a little extension. So if you want that extension, here you go. If you're like, Ms. Lee, I've been bored this whole time. I don't know, like try this, okay? So when we're talking about average rate of change, anytime you see a rate of change, we're talking about slope here. And if you remember slope, right, that's how much is changing, right? So that's going to be your rise over your run kind of type of thing. So, and we're talking about between the interval of 2 and 4. So between the interval of 2 and 4, if you look at here, how much is the y changing from when we go from 2 to 4? So it's going from 0 to 4, right? So that's a difference. I just go 4 minus 0, right? That's going to be 4. And here, this is going to be 4 minus 2, which is going to be 2, right? So literally, my rise over my run is going to be 4 over 2, which is just 2. This is my slope, okay? If you want to use the slope formula, you can totally do that, where you're like, okay, this is x1, this is y1, this is x2, y2. Totally do that if you want to, right? And then if you remember, the slope formula is going to be y2 minus y1, which is the change of y, how much y is changing over x2 minus x1. Honestly, you guys have this in your head already. Like, what's the difference, right, between 4 and 0? Automatically, when I ask you what's the difference, a lot of you guys will say, oh, 4, right? Because you're subtracting your brain, right? So again, that's the same thing. So y2, so 4 minus 0. And this is going to be 4 minus 2, which we still get 4 over 2, which is still 2. Okay. So here, m is equal to 2. Right, we're going to do the same thing here, except we don't have any points. So we're just going to have to find those out. So what happens when x is equal to 2? So we're going to plug in two numbers here. First one for f of 2. So here's f of 2 right here. So we're going to go 2 plus 1 squared plus 20. And so this is going to be 3 squared plus 20. So 3 squared exponents 9 plus 20, which is 29. So when x is equal to 2, y is equal to 29. All right. Now we're going to do the same thing for 4. Let me put that work right over here. So f of 4. So that's going to be, we're just plugging in 4 for x, 4 plus 1 squared plus 20. And this is going to be parentheses first. So 5 squared plus 20. So 25 plus 20, which is going to be 45. And so our point is going to be 4 and 45. Or I should say 4:45. Is that the time right now? No, it's not the time. So if you look at this, so we're going to think about, okay, so we started at 2:29 and we ended up at 4:45. And a lot of you guys will be like, well, Miss Lee, isn't it technically a curve? We're like, yes, but if we're looking at for intervals of the rate of change, we're just going to draw that straight line and we're going to just see what is the average rate of change. That's all. So I'm just going to go 45 minus 29. We're going to take our difference of y's. You have to go in that same way. So if you're subtracting this way, we have to subtract this way. So 4 minus 2. And again, if that, what I just did confuse you, just label one point x1, x2, or x1, y1, and the other one x2, y2. Okay. So right now, how I've done it, the way I've set it up right now is going to be x2, y2. This is x1, y1. Okay. And we're going to just simplify that guy. So m is equal to 45 minus 29, which is going to be 16. Or, yeah. And then this is going to be 2, which is going to be 8. So here the slope is going to be 8. That is the much greater rate of change, which I could have just noticed just by looking at that, because it's only the x difference is only 29, but we went or 2, but we went from 29 to 45. That's like quite a bit, right? So here the slope is equal to 8. So which one has the bigger rate of change? Definitely A, okay? Because this one has a slope of 8, so it's more steep as opposed to the other one, which is less steep. Okay, all right. Homework, it's in your Canvas page. It's also on the bottom here, which I will scroll down to. Oh yeah, it's just practice number 1. See you guys later. Bye.